So this next section of our notes then is all about cloud types, and there are four main cloud types that the spec wants us to explore together. They are, well, the first thing to note here is that you get some of them at the low level, that's below 2,000 meters, then some of them are high level, more than 6,000 meters, and some go across different levels. So the low level clouds, first of all, this is your stratus clouds, this is your cumulus cloud. High level, now this is your cirrus cloud, and then the big daddy of them all is your cumulonimbus that goes all the way up from low level right into the very, very high level cloud. So we're going to take a look at each of these in turn, and you will have some space to annotate them on here for you in your notes, just so you can identify them. There's your stratus cloud there, there's your cumulus cloud there, there's your cirrus cloud there, and then there's cumulonimbus. So as we go through here, just like the last video, there'll be 3 bullet points for each of the 4 types. You just pause the video and you can add them in here. So the first is the cirrus. Take a wee look at the shape. They have those really characteristic shapes to them. So have a wee look at them and see what you see in them. These are the very high clouds, more than 6,000 meters in height. And they're made up of ice crystals, which gives them very often this characteristic white colour. Now, what about the shape? The shape is formed as they're carried by these upper winds, and they're brought into this characteristic hook shape. They kind of look like little wisps of hair or something like that, and those are your cirrus clouds. The second type is your stratus cloud. Now, in complete contrast to the lovely blue colours here, this looks like a grey, dreary day, and indeed it is. These are low, continuous sheets of clouds, typically below 2,000 meters in height. They can come all the way down to the surface. In fact, if you get fog at the surface, it'll be a form of stratus cloud. But normally they're sitting above the ground just slightly. They're relatively thin. So precipitation is unlikely with them. There may be taller clouds hidden above them, but generally speaking you don't get precipitation with your stratus clouds. And they are uniform and a relatively flat base. Now we're used to looking up at them from below, so it's a bit hard to see that. But if you go hiking up into the mountains here and you have this layer cloud, this stratus cloud, you can see the cloud base. It's very, very flat, very, very uniform. But again, we're down below this. These clouds, though, whenever you get up above them, say up on the top of this Sleeve Burner here, you can sometimes get above these stratus clouds. And you can see in this case how thin they are. They're not forming or not going far up into the atmosphere. You can see some of the higher clouds are here, including some cirrus clouds. But this is your low-level stratus, not very thin, and there's a layer cloud. It is pretty cool, I must say, whenever you get up above those clouds and you can stand and have a look down below. There is your very low level stratus layer cloud, and up above there's some of your tendrils of your very, very high level cirrus cloud. Here's another one of it here, the low level stratus. This actually got all the way down to the surface. This was very, very foggy here. But I like this photograph because it shows you just how three-dimensional the atmosphere is. Very low level stratus clouds. Then you've got some mid-level clouds. We don't need to look at those in the spec. And up above those, your high level clouds and your cirrus. Now, do you ever play the game Where's Wally? I wonder, can you find the person standing in this photograph? Whenever I was taking it, there was another photographer out standing taking the photograph as well. Can you spot where they are? It gives you something of a sense of scale. Do you see them yet? There they are there. That little speck of a person. It's a massive big landscape. So the next cloud type is your cumulus cloud type. These are also low-level clouds, below 2,000 meters in height. And they're formed by convection. The ground is heated by the sun, and you get these little thermals of air, these pockets of warm air rising up, cooling and condensing to form these clouds. And these little thermals are a little bit haphazard, so you just get this a random distribution of clouds in the sky, just sitting above where the thermals are producing at that time. And your last cloud type is your cumulonimbus clouds. These are the most dramatic clouds of all, going all the way from the surface up to 6,000 meters plus in height. They're very, very tall clouds. These are also formed by convection, but are very, very energetic. They have pretty well defined lower areas. You can see those edges there pretty well defined. As you get up into the top though, you start to get high enough for this to be made from ice crystals, so it starts to be less well defined and kind of spreading out all over the area. But they're also extremely energetic clouds. They bring with them really heavy rain, and they can bring with them hail and thunderstorm. You can see here what's sometimes called a precipitation core, this area of really, really intense rain that can be produced by cumulonimbus clouds. So I'm going to show you a video, a time-lapse video of a recent cumulonimbus storm that I was under on top of one of the mountains up in the Mournes. This mountain is Douane, and you can see the hail, in this case, coming in. This is a time-lapse, so it's about 15 minutes worth as I sheltered in beside the rocks on top of the mountain. Really did have to shelter because you would have got battered by those. Just see how intense that is, because you can actually begin not to see the mountains. They're all kind of disappearing. As you look back down here, the Silent Valley Reservoir disappeared. But then as the storm begins to pass over, you can see it coming back out again. That short but really, really intense rainstorm that battered us in the form of hail on top of Douane. This was the photograph I took just after I took the time-lapse video. There you can see the hail coming down there at the bottom of the Silent Valley Reservoir. There's the bottom of the cumulonimbus cloud heading that direction, and as it cleared away and as the light came streaming through, you got those beautiful cloud shapes in underneath. Absolutely wonderful clouds to photograph. They can also produce some thunder and lightning, so this is a little bit of a time-lapse video from a thunder and lightning storm that I experienced a few years ago up on the north coast. So these are cumulonimbus clouds far, far off the coast, way over Scotland. So bizarrely I couldn't hear any sound at all from them, couldn't hear any of the thunder, but you could see the lightning being fired off by those amazing big storm clouds and the cumulonimbus clouds that produce that dramatic weather. Most of the lightning is happening in the cloud itself, but every once in a while you'll see a fork of lightning coming down towards the ground. Really looks like the sky is on fire there, doesn't it? And slowly but surely the storm tracked away off towards Scotland, leaving us behind. Not before they treated us to some amazing views of these lightning bolts lighting up the night sky. So, a quick summary then of them. We're looking at our low clouds below 2,000 metres, or high clouds above 6,000 metres. The low clouds are your flat layered stratus clouds. You've also got your cumulus clouds that are produced by convection and give a more patchy coverage. Then high up you've got your ice crystals forming your cirrus clouds, and then my favourite clouds of all, the dramatic cumulonimbus going all the way from the surface to the upper part of the atmosphere, bringing all that wonderful dramatic weather.